Okay, here we go. Start again. You'll see I have a link here for videos, and so I try to record the videos. I try to record the lectures, rather, and post those there. So you can review the lecture material if you want to. Or if you miss the class, you can see it later as well. Okay, coming back to the point I was making. Now, it's not really that hard of a class. It's a lot to do with discipline and how you study for the class. And, you know, different disciplines, different areas, different types of knowledge and skills are all different. So you need different approaches to mastering them. And throughout this quarter, I'll talk about what I suggest as an approach to master this material, which is mainly just practicing. Taking problems and practicing to solve them, programming problems. So this class is about programming. You're not going to write essays. You're going to write programs. So it's kind of like a writing. You know, when you're writing, you want to write for your instructor or you're writing for some audience, and you need your essay to be clear, and you think about the audience that reads the essay. And you have syntactical issues. You want to spell correctly, punctuate correctly, write in clear sentences, and so on. It's similar to that. When you write a program, you have to get it. The syntax has to be right, the punctuation, the symbols. They have to be understood by the computer. Oh, but they also have to be understood by humans as well, because programs, they're kind of like living things. They're always evolving. And they evolve because programmers work on them. They change them. So they're constantly being maintained. You can maybe think of it like your car. You know, you get a new car, maybe it's running well, but then it needs to get fixed. It needs to be maintained. You certainly have to put gas in it. It has to be repaired. Maybe that's not a great analogy, because programs usually, they undergo lots of more transformations than your car might go through. All right, so programs have to be well written. All right, let me come back to maybe the overall structure of the class here. Here's a link to the syllabus. And we have a book. And I don't talk about the book, and I don't assign problems from the book. But the book is maybe necessary for many of you. And you don't have to use this book. You could use a different book. But it needs to cover the same material. But I follow the topics in this book, just how they're presented. And we go up to a chapter, I forget the number, chapter 6 or chapter 8, I can't remember. It's on vectors, arrays and vectors. And then the next chapter is a chapter on pointers. I don't do pointers, right? That's where the next course, Computer Science 202, takes over. They use the same book, and they start from that chapter. I think they review a little bit the chapter that I cover, and then they go into that chapter on pointers. And basically, first 6 chapters of the textbook. And in this class, we're going to learn the C++ language. We won't see the whole language because it's a complicated, difficult language to work in, actually. So we're just going to work in some kind of a subset of it. And we won't look at the full features, but almost. We'll look at the big features, and you'll be able to do significant programs with what you learn here. But it is a difficult language, and that is the language you focus on. And it's similar to a lot of other languages. It's similar to the mainstream languages that's used a lot in industry, like Java. Of course, C++ is used a lot in industry. Java and C#, those languages in particular. C++ is very similar to. And here's a list of learning objectives, and we'll talk about those as we go along, perhaps. And there's a sequence of assignments. I also call them labs and assignments. So you have time during the lab session to work on these problems. But you won't be able to finish them all during your lab session. So then they become like a homework, like assignments that you work on outside of lab. And these are very important. And there's some guidelines here on how to do these assignments. Basically, the assignments are you write programs. You solve a programming problem. And you can work on the assignments on the computers that are in the labs. That's JB 359, 358. I think we're meeting in 358 this quarter. That's our lab room. But you can also use the computers in the other lab as well, 359. Those are identical. But you don't have to work on those computers. You can work on your laptops or a desktop at home, or you can work anywhere that you have access to a C++ compiler. So if you want to work at home, you'll need to have a C++ compiler. If you have Windows, then you can use Visual C++. There's let me show that to you now. Visual C++ Express, or Visual Express. Let's look at that. So you can get this for free. This is from a product from Microsoft. So this runs on Windows. And let's suppose you go to the downloads here. Visual Studio Community, maybe that's what it is. Oh, here we go, Visual Studio. That's it, that must be it right there. That's probably it. These things, basically you want a development environment that creates programs for desktop computers right here, or laptops. This Microsoft Azure, that has to do with creating programs that operate with the cloud computing platform for Microsoft called Azure, which is like blue skies, right? So cloud computing. And Visual Studio Online, yeah, it looks like it has also cloud computing and functionality that lets you work in teams. I think that's what that is. This is the first time I've seen this. But this middle selection here, this is the standard tool that you need. Now, if you have OS 10, like I have a Mac here, so I don't run Visual Studio on this. I run Xcode. So if you have a Macintosh, you can install Xcode. Xcode is free. You get it from the App Store. So look for that, download that. And if you're running Linux, then that's easy. Then you can use your whatever package management tool that you use. You need to get a program called GNU C++, something like that. So those are the three main operating systems, OS 10, Linux, and Windows. There are C++ compilers that are free that are available on all those systems. And, I'm going to always do things in a different order all the time. Let me see what I have in here. Stuff from last quarter. Look at what I'm doing here. I'm working on what's called the command prompt, or the terminal window. Right? So in this class, you need to learn how to work at this console window or terminal window. So, and it's actually in the labs, the first lab, you get comfortable working with this terminal window. And every operating system has one. So, Windows has one, this Mac has one, and the Linux machines in the lab. So the lab machines have Linux installed on them. Now, Linux is a type of Unix operating system. And OS 10, which I'm running here, is also a Unix operating system. So Mac and Linux systems look very similar. The commands are pretty much identical when you're working at this terminal window. But on Windows, there's some differences. There's some overlap. There's similarity. But there's also some differences you have to look out for. But Windows is not really designed to support the command working at the command line very well. So it's kind of cumbersome to work at the command line in Windows, although you can do it. And in fact, you have to do it sometimes if you're doing work on Windows, especially system administration work. You really need to know and understand the command line. So this thing that I'm showing you here is the terminal program, the console program for Mac OS 10. And I'm looking, I'll just start talking about it. See that? This is called a command prompt here. And it's a set of symbols that provide me a little bit of information. Actually, I can see that tilde. That means my current directory is my home directory. So tilde. And that's the same on Linux and the same on, I don't think Windows uses that. But all Unix systems use tilde as an abbreviation for the home folder. So you've got this file system. You've got files on your computer. I'm sure you're familiar with files on your computer. And how they're organized into folders, and your folders can have folders. Right? So that's a file system hierarchy. And so when we write programs, what we do is we create these files that that contain the programs. So we can open the files up in these editors, modify the contents of the file, save them back into the file system. And then we use the compiler to transform those source code files into executable files. And then we run the programs by launching them. And I'm just kind of giving you everything all at once here on day one. But actually, you'll see as we go along, I just repeat a lot. I say, oh yeah, that's what he means by compiler, or that's what he means by such and such. So it's pretty much give you the whole picture from very early on in the class, and students tend to get a little confused, but through repetition and through hands-on experiences in the lab and on your machines, then it starts to sink in, and you get comfortable, really. And it goes pretty fast, in a week or two, you're going to be pretty comfortable. You'll be pretty comfortable with what? You'll be pretty comfortable with the development environment. That's the system, that's the computer that you use to write programs and to run them. It's called the development environment. So you need to get used to your development environment. You need to get familiar with how the process works. What are the tools that you have? And there are, of course, different development environments. And the more you learn, the better it is for you if you need that later on. And many people do need that. Many people become involved in computer programming. I mean, I know a lot, obviously. I'm a professor of computer science, and students that I work with graduate, and what do they do when they graduate? They get jobs as computer programmers. That's what they do. Okay. And when they get those jobs, in many cases, they need to understand how to work in Windows, in a development environment set up for Windows. There's a couple of seats around here, over there, yeah. And they need to know how to work in Linux and Mac. I mean, that's it. And then they also have to, of course, know mobile phones, Android. I forgot to turn my phone off. at iOS, programming for tablets, for cars, for all kinds of devices you write programs and run in. But of course, your phone does not have a development environment. You don't write code on your phone and compile it and then run it on your phone. You might be able to actually, but in a very limited way. So the development environment is a computer that you use to write the source code. So that would be a Linux system, Mac, or Windows system. I know a lot of the coding that I do, and I don't do a lot of C++ coding. That's what I teach here. But there's so many different programming languages, and I work in other ones. And the ones that I work in, it doesn't matter what your platform is. And also you generally work in teams. You work with other people. And in those languages, it doesn't matter. It's not like everybody has to have Windows. It's like, well, you want to use Windows, that's okay, because you can get to a point of where you're detached from the underlying operating system. That's very convenient. There's open seat. There's a seat here, and there's plenty of seats actually. Okay. So let's go back to here. I'm going to show you the basic thing that you're going to do over and over and over again. Here, I'll show a few commands to you. Here's clear, print working directory. That shows me the path to my current directory. So there's this thing called a file system. There's folders within folders, right? And when you're at the terminal window, there's this concept of a current directory. So you're somewhere in your file system. And PWD shows you where you are. Print working directory. It's your working directory. And then I have commands there. I know that there's if I go ls displays the contents of my current folder. So it's like list contents. So these are all of the things in my current working directory. Some of these are files. Some of these things are folders. And I know one of them is a folder called 201. So if I go ls 201, see ls takes an argument. If you omit the argument, it assumes that you want a listing of your current working directory. But now I don't want a listing of the current working directory. I want a listing of a subfolder in my current working directory with the name 201. So I use that syntax there. You see that? Just to finish a thought that I had before, this is a prompt and it has information in it. And the tilde means, if I cd into 201, like the tilde is now 201. It's just it's the name of my current folder. And the $sign means I'm a non-root user. If I switch over to the root user, then I'll see a hash symbol. So there's information in the prompt there. And also I've modified my prompt. See right here, this command? This is a configuration file. And this first line here configures how my prompt is displayed. I like a very simple prompt. So the default prompt that you might get in an operating system is too long for me. So I like to whittle it down. And you just have to look it up in the documentation. And this is how I configure my prompt. And you can see I've got other configurations in there. And that's a file .bashrc. This is common across Unix systems. Well, if you're running, there's different terminal programs. And the terminal program I'm running is called Bash shell. And it's one of the common ones. There's other ones too. But this is the configuration, one of the configuration files. Modify how this console program operates. You won't necessarily need to access that though. You might though. you're a computer science major, you should learn about it. Now, what I'm going to do here is I'm going to rename the 201 folder because I want to start from scratch, but I don't want to lose the work I have in there. And I'm going to rename 201 to old 201. So I use the move command. MV is for move, but I'm using it like I'm renaming. So you can move something from somewhere, from a file or a folder in one location to another location. What I mean by location is a folder location. Files and folders, you specify their locations by a path to the folder that they're in. Remember, my current working directory is /user/Turner. So this 201 was a folder inside another folder called Turner. And I moved it, well, I renamed it essentially, but you use the move command to do a rename. On Windows, you don't use move to do a rename. I think you use rename. But that's from years ago when I used to use that. I think that's right.
Oh.
Yeah.
So when you did the move, you mean like it made a new folder for you?
No, they just renamed it.
Okay.
Yeah. So the 201 folder is missing now. Watch. No such file or directory. But there's the old 201. Oops. That's down there. I renamed it. But I want a new folder called 201. So I'm going to use makedir, MKDIR, make directory. You need to know this. And look what happens. Nothing. That's good. That means no error message. But now it's there. It's by ls201. It doesn't say no such file or folder anymore. It just shows nothing. Nothing in there. And actually, I can use a parameter with this this command, -a, which means show everything, because ls keeps some information hidden. I say show all. Like it shows a dot and a dot dot. Those are kind of like pseudo folders. Every folder has a dot and a dot dot, except maybe the root folder. It does have a dot dot. I never tried that before. Ah, I thought it was in the root, and I use ls, and I'm in the root, like pwd. See, it's just slash on what's called the root folder. I'm at the top. And I'm saying I want to see what's in my parent. I do ls dot dot. So dot dot means your parent folder. I never did this before. And it's because it's a Mac thing, I guess. It's telling me this is in my parent folder. Wait, that's the same thing as my current folder. By the way, the current folder is dot. Yeah, so dot dot is just reporting the contents of my. So the root folder has no parent. So when I do ls dot dot, it's just the same as ls dot. Once again, dot is shorthand. It's an abbreviation, or it's a symbol that represents the current folder. And dot dot represents the parent of the current folder. And tilde represents what? This thing called the home folder. Every user has a home folder. So I can do cd tilde to change to the home folder. And this is my home folder. I go cd slash, that's to change to the root folder. See the prompt? My root folder has got nothing in there. By the way, the slash is called a delimiter. So when I did pwd here, the slash is used to separate folder names and file names. So that's called a delimiter. A delimiter is something that separates things. Like normally when you write sentences in English, the space is a delimiter. So that's how you can see when a word ends and another word begins, because there's a space. That's called a delimiter. Or maybe there's a period or a comma. Those are delimiters. So delimiters are needed when you work with computers. If I go CD, enter, well, CD means change directory. Change a working directory. When you don't give it an argument, when you don't type anything after it, here I gave it an argument. I typed a symbol after CD, tilde, which is your home folder, represents your home folder. But if you omit all arguments to CD, it puts you in your home folder. So CD by itself and CD tilde are the same thing. And CD users, users Turner, that's the same thing as well. So these three commands that I just did on my system are identical. Of course, if I was logged in as a different user with a different name here, I would have a different home folder, but this wouldn't change. Those are still put me in whatever home folder is associated with me as a user. I'll go there. I'm going to CD into the 201 folder. See that? Where am I? If I do print working directory, look, I'm down a level, so I'm now 3 levels down from the root. I'm under users. There's a folder in the root folder called users, and in that folder is a folder called Turner, and that folder is a folder called 201. And in here, I'm going to create a file. I'm going to create a file called main.cpp. I'll put the word hi in it. Well, most of you don't work at the command line, so I'll show you what that looks like. This is a home folder here. And here's the folder called 201. And that's that file we just created, main.cpp. Let's see, how can we look at that? Can I get info? Look at it's the preview here. It just says hi. Look at that. So this tool here, which is like this file system browser. They call it the Finder on Mac, right? And on Windows they call it the Windows Explorer. I like to call it a file system browser, or I don't know, whatever. It's just the file system tool. It shows you your file system. So a lot of people just use this to work on their files. But the other way to do it is to work on the command line. So you use ls and cd and pwd, and you basically have a different view of the same thing. Both of these tools, the console window and this file system browser, they both are presenting similar information. They're both tools to work with the files and folders.
What does VI stand for when you create?
Oh, visual. It's like a visual editor. It's a very old, antique program that's always found on Unix systems. And if you're going to be a system administrator, you might want to learn at least a little bit of VI, because it's everywhere, except on Windows, not on Windows. It'd be like Notepad on Windows, but it's of course more powerful. But when computers were first invented, or not when they were first invented, but at some early point in the evolution of computers, there was no such thing. You never saw anything like this. This is a window. See this window? In the early computers, they didn't have these windows with programs running in windows like this. All you saw was that. That's it. Just text interface. So this console window, this command with the command line prompt, this is the standard interface from early computers. And this is all you used to see. That was it. And then hardware became more powerful, and the software that was running in the hardware became more sophisticated. And devices like graphics cards, graphics interfaces, and monitors were improved. And now we have these, they call them graphical user interface windows. So this is a browser, this is a program. The browser is a program, and it has this window. See? It runs inside of a window. And here's another program, this Finder, file system browser. It's a program. It runs inside its window. And the console, although it used to be everything in the past, now it's just another program that runs inside a window. See? And you'll see that although even though you've got tools like these graphical tools, a lot of times it turns out to be easier to work with a text interface, with the command line tool. And especially if you're doing things like system administration work. Maybe you're managing a lot of servers, or managing websites, or big, big websites where a single server is not big enough. You have to have a bank of servers and lots of databases and very complicated architecture. And you'll see a lot of the times you need to work, it's better to work in a console window. I mean, not always, but in many cases. I've got this little virtual screen, so I'm toggling between two screens. It's just a program that I use so I can work more quickly. So let's do this. Let's go through the basic sequence that you're going to repeat, especially in lab in particular. We're going to write the source code for a program, then we'll compile it, and then we'll run the program. Here, I'll show you how to do that. Well, let's take a look. And I want to go over more of the syllabus in a minute, so we're going to come back to that. Here's the first lab, which is the command line. Lots of stuff to read here. These are the commands you need to learn. pwd, cd, ls, mkdir, remove directory. So you work on those in lab today, or on Wednesday if that's your lab. These are these symbols that I talked about already, dot, 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 and tilde. Now here's an example. Here's an example of a simple program. It just says hello. And I'm going to do it a line at a time, I guess. So the first line is this thing called include. It's an include directive. It tells the compiler to include a header file called IOStream. So we do that because we need to access some functionality in the system that's not provided by default. So we have to tell the compiler that we need functionality that's in the IOStream part of the standard library. And the computer languages have these things called libraries. And that gives, it's not part of the language, well, it is part of the language, but the basic language, like how to do multiplication, how to do assignment, how to define a function, that's like fundamental grammar of a language. And then beyond the grammar of a language, there's all of the functions, the functionality that's provided to you through what's called a standard library. So all of the functionality in the standard library of C++ is not available to you by default. You have to sort of unlock it or open it up by using these include statements. So what we're going to do is we're going to print the word hi to the console, to the command line, to the console window. And so we're going to need some things from this part of the standard library. And then there's this thing called an entry point. So programs are comprised of functions, many functions. And there's a function called the main function, which is the entry point. So the compiler looks for this main function. And it says, well, that's where I'm going to start executing the program. It needs to know where to start running your code. So your program is like this sequence of instructions. But the compiler says, well, I don't know which instruction you want me to run first. So this is the one. Call this function and execute the first instruction in that function. That's the first instruction that runs first. So this function main has two arguments. The first argument is argc. You know what? I think those are optional. I'm going to see. I think your compiler will probably accept this. If not, you have to put in. You'll have to put in all these arguments here, these two arguments. This is the standard form for main, and I don't want to get into that detail right now. But a lot of compilers will let you omit that and just show this empty list inside what's called the argument list. So let's see if that works for us. So you have a function, and then it sort of opens up. It has this like a left side bookend and a right side bookend, and then you have the books in between. So you have this called an opening brace here, and a closing brace there. And in between those, you have instructions or statements. We have one statement and another statement, and so on. So these functions are just sequences of statements. A statement is a command that you're giving to the computer to do something. And we'll be learning about how to form different statements to accomplish different tasks. So when this program runs, statement 1 will run first, then statement 2 will run, and then so on, until it gets to the end, and then we're done. And the function, although I believe this is optional on most, I think I'll leave it out. Talk about it later. So let's look at an example of a statement. Here's a statement: cout, std cout. So we're going to print the word hi to the console window. And this set of symbols here represents what's called a standard output stream. And this thing is an operator which says, send something into the standard output stream. And this right-hand side of that operator, I mean, let me just to make it more clear, it's something like this, like A plus B. You see that? This is like, this is an operator, just like plus is an operator. Then you have the left-hand side, which is A, and you have the right-hand side, which is B. I mean, the left-hand side could be something more. It could be, A minus C, something like that. So, but I'm talking about this operator here, this plus operator, has a left-hand side, which can be of any level of complexity. Just a simple variable like A, or it could be a more complicated expression. Or it could be a complex expression like this one here. So you have so relative to this operator that I have highlighted, there's a left-hand side and a right-hand side. And that's how you should look at this. This is an operator with a left-hand side and a right-hand side. And the left-hand side needs to be an output stream. There's different kinds of output streams. You can write into a file. You can write into a socket. A socket is a connection over the internet. You can write to the console window. You can write into the input stream of another program. So there's all kinds of streams where you're sending in data, you're writing in bytes of data into a stream. And so this left-hand side is a stream. It's called an output stream because we're sending into it. We're sending out of our program. We're sending data out. So this is called an output stream. The opposite is an input stream. We're pulling data in from an input stream. So this set of symbols here represents what's called the standard output stream. And then this is just raw data. It's the characters H and I. I'm just saying take H and I and send it into the standard output stream. I'm going to save that. And then here, I'm going to show this to you again. I just saved those changes. See that? You can see that I saved the changes. You can see it down here, okay? And now we're going to run the compiler, C++, or maybe it's G++, something like that. That's C++ on my machine. C++ compiler. And then it's a command. C++ it's a program. A compiler is a program. We're going to run it just like ls is a program, pwd is a program. We're going to run this program, and we're going to pass it an argument, which is the name of the file to compile. We're saying compiler, the C++ compiler, read the contents of this file, translate it into an executable. And there's errors. This is what an error looks like. Use of undeclared identifier A. I can see it's on line 4 right there. See, this is just garbage. I put it in there to top, right? But that shouldn't be in there. That's text that the compiler doesn't understand. We can only use expressions that the compiler knows that the compiler can process. That expression the compiler cannot process. Now, if I run this again, silence. Silence is good in this case. It means there's no errors. I do ls to look at the contents of my current directory. There's a new file called a.out. That's the executable. That's the default name that the compiler uses on Unix systems. Not on Windows would be a.exe actually. And how do we run this? On my system, I can't just do a.out. This is command not found. I can't launch it like this. And the reason is when I enter a command on the command line, the operating system or the command line processor searches the file system to find a file by the name a.out. That's going to load that into RAM. You'll see a.out is now a file on the hard drive. Actually, I have flash memory now, so it's in my permanent persistent memory. So it's in my file system. And to run the program, you have to take the contents of this executable file and load it into RAM. And then you have to take this thing called a program counter. You've got to take your CPU and tell it to start executing instructions from some point in RAM that you just loaded that executable into. But when I tell the console program I want to run a.out, it says I can't find it. I looked everywhere. I didn't look everywhere. I looked in what's called the system path. I'm going to echo $path. That's my system path. It looked here. It looked under that folder. That's a path to a folder. It looked under that bin folder. That's a subfolder of a Heroku folder. That's a subfolder of a local folder. That's a subfolder of USR, which is a subfolder under the root. It looked there and it said, I don't see a.out in that location. Now, let me look here. Oh, a.out, well, that's the same thing. So that's a bug in my system. So some waste there. And let me look over here. Is it in there? No, it's not in there. And so these here, if you look at that colon there, the colon is acting as the delimiter here. So this is called the system path, which is search to find executable files. And the system path is this colon delimited list of folder locations. So the console program looks in all of these folder locations for a.out, and it doesn't find it and says command not found. By the way, on Windows, they use a semicolon instead of a colon as a delimiter in the system path. And it's very important for you to understand the system path on Windows. There's a lot of students sort of never get that. And how to change the system path. You go to the control panel, you go into like advanced something, and you get to it. There's a lot of steps to go through to get there, but you can finally get and see your system path and modify it there. And to do work on Windows, you need to understand how to find and modify the system path. And the same on all the systems. You know, on OS 10 and Linux, it's a lot easier. They're the same. It's the same thing. This $path. Well, path. The name of the system is called an environmental variable path, and the $sign dereferences it. It says, I don't want to see the word path. I want you to treat path as a name of something else, and I want to see the something else, not the name path. So this is called, this is, we say dereferencing. We're dereferencing the name path. Path is a reference to something else. I just said echo path, it would just say path, all right? So we want it to say, no, I don't want to echo path. I want you to replace path by what it represents, which is that string. And just to make this complete, I'll show you a place where I set that path. Right here, I'm modifying the path. See the path here? So I'm going path equals $path. So take the current state of the path and append, this is the delimiter here. So take the current state of the path and then append this string. Actually, you also have to dereference this as well. And then have the path set to this new value, this new string, and you need to say export here, otherwise it's only a temporary setting. It doesn't make a permanent change. Okay. I know I'm dumping out a lot of stuff here, so. A.out. So the problem with A.out is that it's not in the path. So we have to say, hey, wait a minute. It's here, compiler. So I could modify the path, and I could modify the path to include this folder. Then it would find A.out. But we don't want to do that because this is just a temporary situation that we're generating A.out here. We don't want to make a permanent change to our path. So we just have to give the command line console the absolute path name to the file that we want to run. You see where it said hi right there? So now it executed the program. The program says just send the characters H and I to the standard output stream. And the standard output stream by default is a console window. We can change that. We can redirect, we can tell the console program that we don't want, when we run the program, we don't want the standard output stream to be the console. We want the standard output stream to be a file called t.txt. So I use this thing called a redirection operator. So it says I want to reassign, I want the standard output stream to be t.txt, a file, not the console window. So now when we run it, we don't see hi anymore. But we do see a new file has been created called t.txt. I'm going to use the cat command here to look at the contents. This means basically dump the contents of the file. And there it is, hi. So we created that file. Just to make that fully clear, let's look at it in the file system browser. There it is, t.txt. And there it is, the hi right there. So we wrote 2 characters into that file. I can delete that file with the remove command, rmt.txt. How do I know it's removed? Because it still shows it here. But that's just the text output from the previous invocation of that ls command. I need to re-invoke the command to look at the current contents of the folder, which does not include t.txt. Once again, you're absorbing a lot of information now, and you'll get used to this. Max 2 weeks, you'll have this. I mean, today in lab, you'll have this, okay? And this is basically what you're seeing today is all of the system administration tools, pretty much all of the tools and tricks that you'll need for the whole quarter, all in one day, just today. You're just learning this today. If you don't get it today, then within a week or 2, you'll have it. Okay, so what was I doing? Oh, one thing I wanted to point out here. Oh, rather than typing in I'm using the history key, so I'm using up arrow, down arrow, because all the commands I enter in go into this history list. So I can go back and rerun commands. So I used the up arrow and I got back to here. Then I can modify it before I run it, and then I just run it, hit enter. But the history list is very convenient. But you see that the characters are merged with the prompt. I want them separated. So what I want to do is I want a new line character. So /n is a new line character. So this will tell the console, print, get an H, then it gets an I, and it displays an H, displays an I, then it gets what's called a new line character, as is, start a new line. And so it moves all the current lines up, and then anything that gets printed out after that starts on a new line. Now, if I run this again, I get the same thing. What's up? I just changed the code. Now, how come I'm getting the same behavior? No, because I didn't compile it yet. So we generated this a.out was generated from the older version of the source code. Now that we've modified the source code, we need to regenerate the executable. Silence. That means good. So that worked. And let's try this now. Oh, by the way, wait, let's do this first. You see how we get a new line now? Now after the I is printed here, the console program gets a new line character and says, oh, that's the end of a line. That's a delimiter, a line delimiter. So this \n, this end line character, is a line delimiter. It's called a white space, by the way, because you don't see it. You say white space. It's an invisible space. Spaces are invisible. Tabs. A space is a white space. A tab is a white space. A new line character is a white space. End of file character is a white space. And there's a whole bunch of white space characters. But those are the main ones. Tab, new line, character turn, and space. Now, this is a bit long to type, right? That whole thing. So there's a faster way to do it. We know a.out is in the current folder. So we're just going to use dot to represent the current folder. And so under the current folder is a file a.out. So I'm going to use this path. I'm going to submit this path to the console program and say, look here. You don't have to search everywhere. Just start in the current folder and then find a.out there. So there it is. That's good enough. Now, if I was up a level in my root folder, then I could do the same thing. I could say, oh, there's a subfolder called 201, and there's an a.out in there. And so this is how I submit this command to the console. And so I'm giving it the path from the current folder to the executable, so it'll find it that way. See? I could also do it like this. There's lots of different ways of symbolizing the path to a.out. Now this thing here, this cout, that's the reason we use this IO string. If we took this out, I'm going to show you that. I'm going to comment that line out. By the way, / starts a comment. So the compiler ignores everything after //. So now it doesn't have the include directive anymore. And so this will generate an error message when I try the compilation. It's saying use of undeclared identifier std. Actually, cout is undeclared too. So std is defined in this IO string. So we fix that bug. We come back here, run the compiler, and it works. See, that's getting your standard cycle there. Now, cout is a name that's in the standard library. And so that's why we prefix it with this std. So all the names in the standard library are in are in a namespace called std. So the programs get very large, so one way to keep things straight is to break the names into namespaces, because there's so many names. Because maybe maybe we use cout somewhere else for another purpose, and then we would have a naming collision. So we use a namespace prefix here to say that we want the cout as part of the standard library. Well, now it's still not a good idea to use cout for other purposes, though, of course. That's not a good idea. But it's convenient to shorten this up and just use cout directly. And we want to tell the compiler to look in, when it sees this name, when it sees the name cout, we want to say, look, compiler, don't just look in the default namespace. I want you to also look to the standard namespace as well. And so to do that, we use another directive. It's not a directive. Using namespace std. We use this instruction to the compiler. We tell the compiler to, when you see a name that you don't know what it is, go ahead and search through the standard namespace to find the meaning of that name. So when it sees cout, it's going to say, oh, I don't know what cout means. I don't have a definition for that name. But, okay, now I guess I'll go ahead and look through the std namespace. And then, of course, it finds it there. And it finds it because we included the header file. There we go. So that's your first job, is to get familiar with this development environment, the console window. You know, the ls command, cd command, those commands here. These symbols, special symbols, these commands, get familiar with that. Just use an editor. You need to use a text editor. And a VI is you know, really arcane, old thing that I use, but you might want to use a different editor, like gedit or Nano or Pico. So in lab, you can tinker with that. And then write your first program, which is right here. And then modify it so it prints, you know, hello Alice instead of just hi. That's the first lab. That's your first experience. So you want to get familiar with the development environment, write your first program, modify it, get to learn those commands. And that'll be your first experience.
Every time you're entering, are you running? Like every time you're pressing enter?
Every time I press enter at the command line?
Yes.
Well, here I'm entering nothing, right?
Right.
But yeah, every time I enter, the console window interprets that as a command, so it tries to do something. So look, it says, what do you want me? Command not found. So it says a command. So it's a sequence of commands. So when I hit enter, it tries to run a command.
Got it. Thank you.
Yeah. I'm going to come back to the syllabus now. Programs submitted with compilation errors receive no credit. I'll show you, this is a compilation error. Cout, that doesn't, you know, that's meaningless. And if I try to compile that, it shows me an error. Error. Use of undeclared identifier Cout. Undeclared, see, it's saying undeclared. You didn't declare it. I don't know what it is. So that's an example of a compilation error. Don't bother to submit programs with compilation errors. They receive 0 credit. It's very easy to remove all compilation errors. That's the easy part. The hard part is a runtime error. If your program doesn't run correctly, you can still submit it, but you know, the amount of credit you get for it is another thing. But if it's a compilation error, it's no credit because it's basically straightforward to fix compilation errors, although it would be difficult for you in the beginning. And for C++ in particular, it's kind of a hard language, and the error messages that you get from the compiler are difficult to understand a lot of times. Programs that are incorrect or do not solve the stated problem will lose some or all points. Okay, that would be, you know, that you haven't solved the problem correctly or it doesn't function correctly. I'll give an example of that. So the first assignment, it says, you know, after you get this thing working, then modify it so it doesn't say hi anymore. Now it says hello Alice. All right, so that's what you're supposed to do. Write this program that says hello Alice. Suppose I said hello Bob. It compiles, it runs, but didn't solve the stated problem. All right, it's supposed to say hello Alice. Instead it says hello Bob. It's a silly example, but so you need to solve the problem that's stated, all right, in the correct way. But this would be like partial credit rather than getting a 0. So a compilation error is a 0. So don't submit programs that have compilation errors. Coming back to the syllabus. So you need to get your assignments submitted by the deadline. Then you have an opportunity to get the full score. If you miss the deadline, you got 1 week to get it in, but you're going to lose 25% of the points. Right? After a week, that's it, and then it's a 0. So it's important you don't submit by the deadline. Don't. Submit 4 days before the deadline if you can. Just be ahead. Because you don't know what's going to happen. You may get stuck on a silly problem. The whole class may be zipping through the assignment, and for some reason it's not working for you. Because there's a 0 somewhere where it's supposed to be an O, but you typed a 0, and you keep looking at it, and it looks like an O. It's one of those really subtle problems that you get stuck on, and it takes longer to solve. No one else accidentally hit an O when they were supposed to, or a 0 when they were supposed to type an O. But you did it that way. And now it's a problem, and you show your code to your friends, people in the lab. No one can figure it out, and you have to work on it longer. So there's going to be times when you have unexpected barriers that you have to fight through. And so if you try to submit by the deadline, you're going to miss it sometimes. So it's better to try to submit early, get it done early. Now, your code has to be compilable. That means the computer has to read it and understand it, but it also has to be readable by humans. And so what we have here is a list of criteria for your source code. This is the readability criteria for this class. We'll spend more time with this later because we're running out of time here, so I don't have time to get into that. But the code has to be neat. It has to be logical, and we'll talk more about this as we go along. Let's read the syllabus. I'm going to wrap it up really quickly here. Jaron Willis is the TA for this class. He'll be grading the submitted assignments, and he'll help you in the lab. He also has some extra lab hours, and he may change these. So talk to him about that when you see him today if you want to come at a different time for extra lab hours. There's a spreadsheet with the grades in it, and I haven't put, you'll be assigned an ID, a numeric ID here. You'll be able to see what we have for your score on the submitted assignments and also the exams, exam 1, 2, 3, and the final exam. You can look at it there. And